So let's do an example here. Let's consider a cube. Okay, and a charge right in the center of it. Q could be 14.2 picocoulombs. And so I want to know how much flux goes through one side of the cube. Now, it's very important to say that the charge is located at the center of the cube. Okay. The reason that's important is that means the electric field, when it goes out, impinges on each side and top, bottom, and so forth exactly the same way. So that's very important. Okay, so to find the flux, that's going to be the surface integral E dot dA. Now, the problem is that as this hits the side, different parts of the side are different distances from the charge. So we know the strength of the electric field is K sub E Q over R squared. So R keeps changing, so that does not come out of the integral. Well, the other thing is the dot product also changes, because the dot product depends on the angle between the electric field and the surface, and that keeps changing. So that means we cannot make that a non-vector integral. So that turns out to be a very difficult and nightmarish integral to do. So how do we integrate nightmarish integrals? We use integration by avoidance. We try to figure out how not to do it. And so what we do is we say, now, I want to know the flux through that side. But Gauss's law tells me the total flux is going to be the enclosed charge over epsilon naught. Well, it's a cube. It's symmetric. The charge is in the center, so that means the flux on each side is identical. So the flux on just this one side, that flux is going to be 1/6 Q enclosed over epsilon naught. Okay. Well, then we have it. So this is going to be 1/6 times 14.2 times 10 to the minus 12 coulombs divided by 8.85 times 10 to the minus 12 Newton meter squared per coulomb squared. And so this comes out to be equal to 0.267 Newton meter squared per coulomb. Now, the charge was on the inside, though. Now, one thing I did not take into account was direction. This should be positive because it is going out. Okay, so if it had been going in, it would have been negative. Now, I did not explicitly state that. You know, we just assumed that it would be positive, but it really is a positive value because the flux is going out. Okay, flux going out is positive, flux going in is negative. And so there we have the flux to one side. So that's through the side. And we managed to avoid the really nasty integral.